Good afternoon. It is my great pleasure to welcome Dr. Robert Brammer back to our campus. Bob currently serves as Vice President for Advanced Technology for Northrop Grumman Information Systems. In his role, he leads the technology strategy and research programs for this $10 billion sector of Northrop Grumman. More specifically, Bob is responsible for the overall technology strategy and independent research and development programs, technology and research partnerships, technical talent development, and intellectual property management in this business unit. During his several decades with Northrop Grumman, Bob has also held several other senior executive positions with the company. Before joining the company, however, he was with NASA and he worked on the Apollo and Skylab missions. We should have had you give a talk on the Apollo and Skylab missions. That's for another day. With a focus on real-time software for tracking command, telemetry, and communications. Bob holds a bachelor's degree in mathematics from the University of Michigan and master's and PhD degrees from the University of Maryland. I guess we can truthfully say all of your degrees are from U of M. So we'll leave it as that. He's a fellow of Woodrow Wilson. He received achievement awards for his work on the Apollo program and for principal investigative research on NASA and NOAA satellite remote sensing programs. He's a fellow of the Society of Photo-Optical Instrumentation Engineers and a fellow of AMS. He's also a senior member of several other professional societies. He has served on numerous government and industry advisory boards, including the National Academy of Sciences, Department of Defense, and NASA, just to name a few. I've had the pleasure over the last 2 years to serve with Bob on the External Relations Council for the Internet 2 Consortium. Bob was recently named by the Security magazine as one of the 25 most influential people in the security industry. Please join me in giving a warm welcome to Bob Brammer.
Well, thank you, Farnham, and thank you all for coming here this afternoon. I have to tell you, I was a little nervous last Saturday afternoon because I was watching the football game and thinking about, in 1967, I was a senior on this campus, and the football team was not very good, and we lost to Indiana. And then in 1987, I came and gave a lecture here on this campus, and that following Saturday, Michigan lost to Indiana. So here I am thinking, oh my God, I'm going back out to Ann Arbor to give another talk, and we're playing Indiana. Well, fortunately, the game ended happily. And I'm staying over for the game this Saturday, and I hope that one ends happily too.
Go blue.
Go blue, right. So, what I want to talk about today are two subjects, cybersecurity and global climate change. And so we're going to talk about the relations between them. And so what I'd like you to get out of this talk are a few key points here. First, these are nationally and internationally significant issues. And there are a number of similarities and differences. Similarities, they're both priorities for the administration, politically controversial, a lot of significant policy and economic issues associated with them, very poorly understood by the general public, active research and so forth. So a lot of sort of top-level similarities. There are also a lot of differences. Cybersecurity incidents can happen at network speeds, very rapid, whereas climate change is, for the most part, you think years, decades, and so forth. And cyberspace is entirely a creation of humans, whereas the climate is largely a natural environment. And of course, some of the climate changes is induced by human activity, but some of it is not. So there are a number of differences in these issues. Now, I think most people would agree that these are important issues, but would probably think of them as being very different from one another and not particularly related. So we're going to talk about some similarities and, more to the point, how these effects, these two issues affect one another. And I think one of the points I would like you to get out of this is that Northrop Grumman, being a very large system integration firm, we have to think about system issues and system of system issues, and often the fact that things you do in one area can have significant effects on others. And so we are forced to take very broad views of things and think about relationships. And since these are two very important priorities in the research program I'm responsible for, I've developed this view on these two subjects over the past some number of years, and that's what I'm going to talk about with you today. So these issues compete with each other in terms of priority and funding. The cybersecurity systems, they consume energy, and that energy in turn has an environmental footprint. So the more you do in security measures, the more you are affecting the climate. Furthermore, things that you could do in an information systems viewpoint, cloud computing, virtualization, and so forth, which may be very good in terms of energy efficiency, reduction, and so forth, can open significant security holes and, in effect, make our security problems worse. So this is an example of, you try to fix something over here and you break something over there. And so you have to keep these issues in mind. And many of the things that we want to do to either mitigate or adapt to climate change will be threatened by failures of cybersecurity. And so we'll talk about some specific examples. And so at the end of all of this, I want to save a little time for the so what. You could go through all this and say, well, this is very interesting, but what does it mean to me? And so I'll talk a little bit about what it means to a large corporation like ours and what I think it means to an educational institution like Michigan in terms of research priorities, educational curriculum, and so forth. So with that, I've organized the presentation with brief introductory stuff, and then we will talk about three areas: political relations, economic, and technical. And then we'll get to some implications and have some time for discussion at the end. Northrop Grumman today, as you see, about 35 billion in sales, 120,000 people, very distributed operation, and a lot of capabilities. And as you will see here, I put this list in alphabetical order so that I don't get silly arguments from different parts of the corporation as to whose is more important. But I did highlight these two because that's what I'm going to be talking about this afternoon. We also, in terms of our internal R&D program, it's about $600 million a year in a variety of technologies, all the way from very emerging technologies to full-scale integration. So the research program at Northrop Grumman is a very critical part of our business strategy, and we allocate resources in a number of different ways. Now, in terms of the climate and environment, this is a very important part of our business. Hundreds of millions of dollars a year in revenue in this area, all the way from building environmental satellites and different types of observing systems, both satellite systems and airborne systems. We do a lot with data management and software. In particular, we help NASA build the Earth system modeling framework by which oceanographic and atmospheric and land surface models and so forth are all tied together in these global climate models that have been used to make predictions about climate change. We do a lot of work in modeling and simulation of various types of climate, severe storms, atmospheric propagation, cloud databases, and so forth. And we also spend a lot of time thinking about the impact of weather and climate on people and systems and operations. We have a very large public health unit, does about $500 million a year in public health on a global basis for the Centers for Disease Control, and so weather and climate issues, water supply, and so forth are very important in that, and spread of disease. So these are issues that we have to think about. Our shipbuilding unit built the U.S.'s high-latitude research vessel that operates in the North Pole in the summer, collecting research observations about the Arctic and the ice cap and so forth. So we really think about climate and environment all the way from the observations through a number of critical applications. Now, in the cybersecurity area, I won't drag you through all of this, but our key programs in cybersecurity include, of course, managing our own corporate network, which is a global network itself, a number of programs for federal civil agencies like the Department of Homeland Security, the Treasury Department. We have a responsibility for the security for the Treasury Department's network, the Department of State's network, big chunks of the Homeland Security network, and so forth. These are our people operating systems in their centers, developing technology, and so forth. For the Defense Department, we have some very large programs. We're responsible for a lot of the activities at the Army, the Joint Task Force on Global Network Operations, and so forth. Do research for DARPA in a number of ways. And also in the intelligence community, a number of classified programs. So our cybersecurity activities are very large and very important, and one of the fastest growing parts of our business. We have a number of laboratories across the country, depending on how you count them. This is well over 100 in different areas. We network them together in a number of ways, and this is not only internal, but as Farnham says, we've been active in the Internet 2 consortium, so we tie to the external research community through Internet 2 and National Lambda Rail and Defense Research and Engineering Network and Department of Energy and so forth. So we use those networks to help us talk with the research community at large. Now, that's a little bit about us. Now, about these two issues, is there anyone here who wants to debate the point about cybersecurity and climate change being issues of global significance? As if you do, I don't think you belong here, but a couple of quotes from the President, but also an interesting paper published by the Secretary General of the International Telecommunications Union a couple of years ago, entitled Climate Change, Cybersecurity, and the Economic Crisis. And so this was written at the time in the fall of 2008 when the banking system was collapsing around the world. And yet his view was strategic enough to recognize not only the immediate crisis, but also two issues that are affecting communications, information technology, and so forth going forward. So there are a number of people here thinking about these issues, and that's the good news. The bad news is not enough, and so there's a lot more work to be done here. So now let's talk about politics for a minute. And here I want to talk about something that happened about a year ago this time. Pat Gallagher was up for confirmation as director of NIST, the National Institute for Standards and Technology. And he was appearing before the Senate Committee on Commerce, Science, and Transportation. That's the committee that has oversight over the NIST budget. And Senator Rockefeller from West Virginia is the chair of that committee. And reading the transcript of that hearing is very interesting because normally NIST is a pretty low-profile government agency. It makes standards in a number of areas, and this is not considered particularly controversial or politically hot subject. However, NIST is very active in both cybersecurity and climate change, and what Senator Rockefeller was telling him is that we recognize those are both your priorities, but we got to do something first about cybersecurity. And so you see this cybersecurity issue is constantly imminent. Your other big subject is climate change, but To be frank about it, in the short term, climate change is much less of a threat than cybersecurity. Cybersecurity is potentially next week, tomorrow, a year from now. Climate change is not. So he's saying we'll get to it when we get to it. However, Senator Rockefeller is a very smart guy. Over the long term, if we don't do some climate change fixing, then the rest of this won't matter. So he's telling you we recognize these issues, but this is one example of these two issues competing for attention, funding, priority on Capitol Hill and in the administration. The second issue that had some political consequence was something that's called Climategate. And some of you may have heard this, but last year, somebody, and it's still not known who, hacked into the email system at one of the UK universities and exfiltrated a large volume of email traffic between climate scientists. And so there was a lot of argument about the interpretation of some of these messages, some allegation over whether some of the climate data was being falsified in order to push political agendas and so forth. This has since been reviewed by a number of committees. In fact, a report was released on this just last week, which said that a lot of this was taken out of context, and yes, there were some things said in email messages that probably shouldn't have been said, but there's no indication of manipulation of the data or any sort of material impact on the integrity of the scientific process. However, and here's the political implication from this. A group at Yale University released a report in July where they announced or analyzed the public opinions and found significant declines in the perceptions of the public at large, and in particular, the results demonstrate that this Climategate incident had a significant effect on the public interest in this issue. Well, of course, that in turn has a big impact on what attention the Congress will give to an issue like this. And in fact, the climate change legislation has stalled completely. And the administration has decided, in the press of other things, not to push it. So despite the fact that this was a high priority when the new administration came in at the beginning of the year, things can change rather quickly in terms of political aspects. So this was a case in which the lack of cybersecurity had some significant political damage for our attempt at addressing climate change. Now I want to talk about the economy for a minute. The energy area, which of course is very tightly coupled to the climate change activities, is a definite priority for the administration. And so if you look at the stimulus funding that was made available, you can see some very large volumes of data were provided for modernization of facilities, billions of dollars for federal buildings and so forth. And some of this actually affects one of the contracts that we got, which I'll talk about a little later, and a number of other areas. So there was some serious money put up for clean energy industry. The president made this announcement at a small company in Colorado that builds these solar arrays. And so even though the climate change stuff has sort of cooled off, so to speak, the interest in energy conservation and so forth is still getting a lot of attention. And it is an economic issue. So now we look at nuclear power. I'm going to give you a very short history of nuclear power in the U.S. In the 1950s, our friend the atom. I had this book when I was a kid, and I read it, and the tagline was, nuclear reactors, and there was some hope even of controlled fusion reactors in those years, and electricity would be available, and it would be too cheap to bother to meter it. It would, in a sense, be free. Well, didn't quite turn out that way. 1979, 3 Mile Island. The U.S. hasn't built a nuclear reactor in decades, but now, President's State of the Union, all about creating jobs. Create more of these clean energy jobs. We need more production, more efficiency, more incentives, and that means building a new generation of safe, clean nuclear power plants in this country. The Nuclear Regulatory Commission has now 17 active applications for building new nuclear generating systems, and of course it will take decades to get these done, built, operating, and so forth. And that, by the way, won't fix our climate problem, but it will certainly, if those facilities are actually built, then that would have a significant impact. Today, the United States has about 100 nuclear facilities, generation, but they're all old. And the nuclear industry has survived basically in this country by maintaining the existing facilities and not by building new ones. But there is the hope that on their part, that new facilities can be built. Of course, somehow this clean, safe, we still got the problem of where do you get the nuclear fuel and how do you dispose of the nuclear waste, which, by the way, is also an environmental issue. But anyway, that is the political dialogue now. However, if you look at what Department of Energy is pushing is the smart grid concept, or the integration of advanced information technology into the power grid. And why are they doing that? Well, reliability, efficiency, and so forth. And this is wording from one of their documents. Contribute to the climate change strategic goal of reducing carbon emissions. So to make the power grid more efficient. The current power grid is very inefficient. About the electric power generated by the power grid in the United States is only about 1% of the energy that goes into it. So the efficiency of it is pretty bad. And so if we can make it more efficient, that would obviously help. However, NERC, the North American Electric Reliability Council, this is the consortium that provides oversight for the reliability of the power grid in the United States, just completed in July an assessment of these smart grid concepts, and you notice reliability impacts of climate change initiatives. And so they're saying, well, let's be careful here. And one of the things they're most concerned about is the cyber and physical security aspects of the power grid. And so let's not take a situation that obviously needs fixing, but do something to make it worse. And then this happened. These reports just came out in the past couple of weeks. A worm called Stuxnet has received a lot of publicity, and those of you in the security business will know something about this, but this was a worm very specifically targeted to a class of industrial control systems developed by the Siemens Corporation, which are used in a lot of industrial areas, but notably in the control of nuclear facilities. And in particular, the nuclear site in Iran was believed to be one of the targets there. And so this is an article from the New York Times published a couple of weeks ago. Global alarm over the deadly computer worm has come many months after the program was suspected of entering the control system for the nuclear power plant, perhaps on a USB memory stick. Little thing like that could cause a lot of damage. And this is a very sophisticated worm that can reprogram the control of parts of the nuclear facility and in effect damage some of the centrifuges made by Siemens and make them fail in a way that would be undetectable and seriously damage the control of the power plant. So something like this could, a few of these incidents could slow down a number of these plants or applications and so forth because of concern over control of these. In effect, another 3 Mile Island or Chernobyl and so forth. So the economic impact from these cybersecurity problems can be significant, and this would be a considerable risk going forward if we don't come up with the right ways of securing these systems. So this is a wide open research area. A lot of work being done in this area by us and by others, but we have a long way to go in terms of addressing this on the scale that really matters. And then another approach to addressing energy emissions, controlling the process and so forth is referred to as cap and trade. And really what this means is that energy caps or emissions caps for a given operation would be imposed. And then if a company wanted to exceed that limit, they would have to buy credits from somebody else who may have some of this and not using up all of their quota, so they'd be in a position to sell something. And Europe has set up an emissions trading market to implement some of this. And the hope would be that this sort of market trading would help provide economic incentives for people to address the emissions and reduce the impact on the climate as a result. However, these are quotes from an article in the New York Times in August. The integrity of these processes is really questionable. And in fact, there are a number of controversies now and some allegations about faking the credits and stealing certificates and think Enron. This is the sort of lack of integrity in the energy trading business led to some significant damage. We have similar problems in the European exchange. And so what you see here is controversy over offsetting is the latest blow to emissions trading, which has been racked by a spate of problems in Europe, including cyber attacks, tax fraud, and recycling of credits. So if we can't get the kind of cybersecurity solid infrastructure for trading markets, this concept is going to go nowhere in the United States. And there are enough ways to criticize it, but without the right kind of security to maintain the integrity of the process, this has no chance of getting enacted in this country. So let's move on now to the technical issues. Major focus on data centers. In 2007, the Environmental Protection Agency was required by the Congress to produce a report on the impact of data centers on energy emissions and the use of electric power. People have been observing a rather rapid growth in the use of electricity for powering data centers. And in fact, some of this data motivated a proposal coming out of here for energy efficient electronics. And some of the data about the growth of electrical consumption and so forth was actually used as a part of that proposal. This was a 2007 report, and it observed that data centers use about 50 times the energy per square foot as normal office space. And what was really getting people concerned was that data center power consumption was on a path to double every 5 years. So even though you might say, well, it's only 1.5% of the electricity in the US, that's actually a fairly significant number. And if that doubles every 5 years, if we don't do something over a decade or two, this is going to be a very significant issue. And for an IT manager, what a lot of the guys have found is that, you know, the fraction of their expenses, which used to be dominated by the computing and communication, is now being dominated by the energy requirements. You know, one of the guys told me, he says, I spend about half the energy budget powering these systems which heat this place up, and the other half on air conditioning, cooling it down. I mean, this is a terribly inefficient process. Well, so a lot of attention was put into it, but here we are in 2010. This is a report a few months ago from the Gartner Group, and data center power, cooling in space is still a problem. Frankly, we haven't made a lot of progress with it, despite a lot of talk about it. And the biggest issues faced by data center managers were power, cooling, and space problems. And so what are people trying to do about it? Well, virtualizing servers, consolidating data centers. I mean, these are sort of natural things to try to do. Well, these are causing problems. Information system architecture changes. Anytime you make a significant change like that, you better think about the security implications of what you're doing. Here's an article that I think articulated some of the issues fairly well. It came out of one of the security publications last month, and it quotes another Gartner study that says that 60% of virtualized servers deployed in the next year and a half will be less secure than the physical servers they replace. Well, this is not progress. I mean, they may consume less energy, they may take up less space, but if you do this at the expense of creating security holes in your network, I would argue that you need a better approach. Virtualization, of course, is a big chunk of the cloud computing, and there are a number of companies offering cloud computing services, and a number of guys like us saying, hold on, you know, there are a lot of security issues associated with cloud computing, and that's true whether it's public clouds or private clouds. And so an industry consortium called the Cloud Security Alliance has been formed to try to come up with some standards and processes and so forth to address these security issues. And we are a member of this alliance, along with a number of other companies, and we are trying to grapple with these issues because, you know, if you could solve some of these problems, some of the cloud concepts are good. You know, buy the information technology infrastructure, you know, on a usage basis as opposed to everybody building their own data center. Analogies have been made to the electric power industry, where in the 1900s or the 1800s, a lot of companies started building their own generators. And eventually utilities formed and made electricity a service. Now, I would argue that that's a poor analogy because, you know, electricity is basically a one-way thing from the utility to us. I'm not storing my sensitive private information in an electric generator, so I don't think the analogy works for me, but the fact is that, you know, a more efficient way of managing IT infrastructure would be a good thing for a lot of reasons. But, you know, one of the things I thought was interesting out of this article was that just consolidating federal data centers has been tried before. In the mid-90s, the Clinton administration tried this for cost reduction. And at that time, the feds had about 200 data centers, and they said, well, that's too many. We don't need 200. We got to reduce the number. Today, there are about 1,100, so this was not a wildly successful initiative. And so they're trying it again. But again, if we do this in the sense of increasing security vulnerabilities and so forth, then we haven't done it right. So the objective of addressing the cloud architectures and reducing the energy consumption, reducing the impact on the climate and so forth is certainly a very good objective, but you can't do it at the expense of decreasing the security. Now, at the micro level, there have been some research concepts to change computer architectures to improve security. And one of these is called dynamic information flow tracking, and there are a couple of papers here, including one by Srini Devadas, who's at MIT in their Department of Computer Science. And I don't really have time to get into all the details, but basically what this says is put some extra bits on the word length and use those bits to track the information as it flows, and then you can detect what information is being used in some unsafe ways. And we did some initial testing of this on some titanium chips because they had a way of using some extra bits on their speculative execution. But extra bits for security purposes consume energy. And so you want to be sure that if you're going to lengthen the word or increase the word length and increase the processing, that implies some additional overhead that will consume energy, and that will add to the problem that we're trying to fix. So what we've been trying to do is trade-offs there of if I change the architecture of the chips, and by the way, this would be a long-term thing because Intel and IBM and others have not done anything about this yet. This is purely a research concept, but if we had a success in terms of some of the research, then we would probably make an arrangement with those companies to produce chips that would have such an architecture, and then over time maybe that would do us some good. So the architectural changes, even at the micro level, raise some of the same kinds of trade-off issues. Now, on a macro level, we just won a large contract to build the system at the new headquarters building for the Department of Homeland Security. And this is in downtown Washington at the location of the former St. Elizabeth's Hospital. St. Elizabeth's was a mental hospital, and that came up a few times in the course of writing the proposal, but setting that aside, our contract calls for us to build the IT infrastructure and secure the operations, the access control, and provide a number of services. But DHS and the administration have placed a huge emphasis in this area, the smart building and green management systems. They want to minimize the use of energy in this building. At the same time, they want a highly secure facility. So we will be doing the sort of trade-offs that I've been talking about between energy efficiency and increased security on a very large scale for DHS as we work the architecture and eventually the operations of this new headquarters campus. So this has the opportunity of being an absolutely state-of-the-art, leading-edge program balancing high security requirements with high environmental impact requirements. And learning how to do that on this kind of scale is a very important objective. Now, I'd be remiss if I didn't say something in Michigan about the automobile industry. And so certainly this industry has a huge impact, environmental impact. Transportation industry is responsible for burning most of the petroleum in the world, and the road transportation is the biggest part of that. There are now about 600 million cars around the world, and so the energy efficiency of those cars is a big deal. Now, modern automobiles are very computer intensive, and most of the new ones have maybe 100 computers, some of them even more than that, and there are some internal networks or buses that have been designed, and a lot of the objectives are to improve the efficiency of these automobiles, reduce the cost, improve the maintenance, increase the gas mileage, and so forth. All of those very good objectives. However, they were all designed with no attention whatsoever to cybersecurity issues. And so now a group, University of Washington and University of California at San Diego, has established their Center for Automotive Embedded Security and published an interesting paper a few months ago called The Experimental Security Analysis of the Modern Automobile. And they didn't, they did their testing on a couple of cars. They declined to say which cars they used because they said we could have done this on any cars, so we didn't want to pick on anybody. But here are a couple of quotes from that paper. It is possible to bypass rudimentary network security protections within the car, and they did that. And they have demonstrated the ability to take over the car. They can control the brake system, they can disable the brakes on the individual wheels, they can stop the engine or control the accelerator, and the driver would have no way of controlling this at all. Moreover, they got in to some of these cars through systems like the OnStar, so they could communicate, not only hitting one car, but communicate the virus malware to others. And so if you had an implant, say at a maintenance facility, the diagnostics port in the car is just a USB port that's totally unprotected. Or if you get it in through some wireless system on a large scale, and if you imagine the right kind of sophistication in the malware, sort of like a Stuxnet for cars, 3 o'clock Thursday afternoon, every car in the United States goes nuts. Well, this would be a terrorist incident on a massive scale. And, God forbid something like that should ever happen, but we are continuing to build systems on a large scale that do not reflect any attention whatsoever to security issues. And a lot of this is being done because we're trying very hard for energy efficiency, cost reduction, and so forth. Well, again, I would argue we have to think about the whole problem here, and these connections keep coming up over and over again. So, in conclusion, what does this mean to industry? Well, to us, we have to look at everything we do through a cybersecurity lens. We build some very large information systems for critical national applications. So we crawl all over these things to make sure as best we can we've addressed the security issues. Not that we're making any claims to have solved all the problems. We can't do that, and neither can anybody else. But we sure think about it and do the best we can with it. And this, by the way, there are a lot of legacy systems that are out in the field, and these were put out there years before these threats were recognized, and yet they still have these vulnerabilities. And whether these are defense systems or civil systems and so forth, there are a lot of very vulnerable systems out there. So we have to do that, and we have to do that in a way that recognizes critical lack of trained people in this area. There's a very good report issued in July by the Center for Strategic and International Studies about the workforce issues associated with cybersecurity and the fact that we don't have enough trained people, and we are not, in our current course and speed, we are not going to produce them for a while either. So we have increased our own internal training programs. We're establishing relationships with various educational institutions and security certification companies and so forth. This is a big deal issue for us, and I would argue that it ought to be a big deal issue for a lot of other people. Now, what about academia? Well, I would say that both energy efficiency with the climate implications and cybersecurity should be taught at some level to all of the students. Not that everybody needs to be an expert in this stuff, but there needs to be a broad awareness so that we don't have this sort of political uncertainty and lack of understanding of the public at large on these issues that we have today. And then I would say that every student in science and engineering needs to have a very good understanding of these cybersecurity and energy efficiency issues. We can't continue to design systems like cars with no security defenses at all. And that's just one example. Power grid, anything else. So this ought to be part of the educational curriculum at all of our universities. So, and it's by no means any longer just a computer science issue. It's gone way beyond that. And so when you're talking about power systems or automobiles or transportation and so forth, everything, we're in this rush to computerize everything, and for many good reasons in terms of cost savings, energy efficiency, functionality, and so forth. But we can't do this without the right attention to the security implications of this. And there is a critical shortage of qualified graduates. And so we're looking for them, and so are a lot of other companies. But we need to be sure that we're producing the graduates in a way that they are educated to step into responsible positions in companies like ours. So I think this is what does this mean to academia? I think we need to think very hard about the curriculum in various ways and to recognize some of the changes that have to occur in order to address some of these challenges that we have in the 21st century. So I think with that, I will stop and throw the floor open to any questions you want to raise.
Time for a couple of questions from the audience. Bob, I'll start while...
Yeah, let them warm up a little bit. Yeah.
I was wondering what fraction of U.S.'s current energy needs are met by nuclear energy, and what do you think that level should be?
I think today it's about 20%.
20%?
Yeah. The nukes, they operate continuously, and they're usually at the bottom of the stack for the power companies. But, it's not anywhere near what coal is, which is probably closer to half. Then you have natural gas and some other sources. But whether nuclear power becomes a larger fraction than the current level or not, I think is a very questionable issue right now. I mean, there's certainly more interest in it, and we see that reflected in the applications to the Nuclear Regulatory Commission. But whether those will be approved, whether there'll be enough concerns over the security issues and so forth, whether those can be addressed in ways that satisfy people, I don't know. I think that's an open issue.
And an unrelated question, but you mentioned that a number of essentially security issues that you mentioned are all related to SCADA systems, having to do with infrastructure, control systems, and so on. Do you see a much more willingness on the administration's part to fund essentially academic research for those types of security as opposed to internet security and cyber attacks?
Yeah, most of the cybersecurity stuff right now is going toward computer networks. But I would argue in 5 years that this could flip entirely, that there may be more attention, there should be more attention to the infrastructure networks. And I think right now most of the government agencies are trying to figure out what to do with this. I mean, I see a little interest at DOE in this. I see some interest at low levels in other agencies, but it's not much right now. And, I've talked to some senior research managers in some of the government agencies, and they say, well, this really isn't my problem. That most of the critical infrastructure in the United States is not government-owned. It's owned by private industry, and they had to go fix themselves. So we don't have a national consensus on what to do with this problem yet.
I'll just add, I've worked with a number of utilities, predominantly on the West Coast, and they treat the security of the data signals in their SCADA system very serious. They have dedicated networks for the information flow. So it's certainly something that is very much on the minds of the utilities.
Yeah, this is a newfound religion, and the NERC tried to address this shortly after 9/11 with some new security requirements, but it's been pretty slow to roll out across the industry on any scale. Those protocols for the SCADA systems are pretty much wide open. Free text, they're not encrypted, and a lot of these sensors are set up to allow maintenance. I mean, when the electric power industry says security, they have traditionally meant what I would consider reliability. They want to keep that power available. That's been their priority. And so things like, weather incidents and so on, they're used to dealing with those issues, and they handle them by and large pretty well. But every once in a while we see a massive blackout like we had at in August of 2003 in the Northeast, and a lot of the infrastructure really needs to be modernized in this country. And you're right, over the past couple of years there's been a lot more attention paid in these utilities to these issues, but getting that rolled out and implemented on a wide scale in the country is still a challenge.
Well, on that note, let's thank... Oh, I'm sorry. Go ahead, Igor. I didn't see you. Go ahead.
So it seems very difficult to quantify security of a particular system, especially if we would try to formulate the minimum required level of security. I wonder if there's some sort of organizational infrastructure that would allow it to do it.
Well, you're right. There is no natural unit of security that we can use. What's a yard of security? We don't have a metric for it. And that's been part of the problem. And the economics of security is how you value it. How you would trade off an investment in security as opposed to something else. There are a number of attempts now at security economics, and there is an annual conference now on a workshop on the economics of information security that is starting to produce some results. This is still a problem, and attaching the right level of risk to certain types of vulnerabilities is a challenge. So, still a research area, a number of people working on it, and so over time it will improve. But at the moment, the economics would suggest that you somehow try to figure out what your biggest risks are and deal with those first. And you can't deal with everything all at once. You don't have the budget and the staff to do it. So you have to tackle the biggest problems and do the best you can with it. But yeah, it's very ad hoc and not quantifiable at all right now.
Before we wrap up, any other questions? Right. Well, Bob, it's rare for us to see a presentation that covers both technical and policy issues. Let me thank you again for visiting with us today. Join me in thanking Bob. And he's going to be around for the next half an hour or so. You're welcome, especially our graduate students who want to chat with him. Come forward and meet Bob. Thanks, again.